I'm Hassan Ziada from Mechatronics. My team member is SE Chavash. They will be doing the presentation about the rental offers in Germany. We got this data set from Kaggle. Our presentation, our machine learning model will be about predicting the rent prices from this data set by using this data set. The machine learning task will be supervised because we have the features and we have the target value, which is the total rent. Why we chose this data set? Because it is not easy for humans to predict the rent prices of the house because there are multiple factors that should be taken into consideration when predicting the rent prices. Especially for people who are new to the countries, uh, so our model will help people who are new to the country or generally people who have difficulty predicting the rents and the rent prices in general. Um, it could help prevent people signing overpriced housing deals and protect them from being scammed. And it could help choose an area to live in where rent prices are in one's budget. This is the dataset summarized. We have a total of 268,850 samples. We have 40 features, 9 are methods. Most of the missing features are not vital. This is a visualization from Orange. First, we explored the correlations between our features. First, we did the Pearson correlation, where we saw low to no correlation and when we did the Spearman, we actually saw a more significant correlation. Now Pearson is a linear correlation, but we didn't see anything significant using that. And Spearman, it shows the nonlinear correlation, but we want to note that when there is no linear correlation, it doesn't mean that there is no correlation. So we went with the Spearman correlation. This is the visualization. This is obviously before the pre-processing. So this is the graph for base rent, total rent. We have outliers, as you can see in both the total rent and base rent. After the pre-processing, we will, as we will show you later into the presentation, we will show how these graphs change and start making sense. This is the total rent and living space. As you can see, we also have, as I said, this is before the pre-processing. So in the living space, we have like 60,000 meters squared, which is a very unrealistic number. We will take care of that, obviously, after the pre-processing. This is the year constructed. Now, in the year constructed total rent graph, it almost makes sense. It's between the thousands and the 2000, beginning of the 2000s. And if we take into consideration that Germany does have ancient buildings, this should make sense, except for a bit of outliers that go farther than 2022, of course. This is the condition graph. Uh, as we can see, most of the houses are well kept, which is what you would expect from someone who is renting a house or from the flats that are shown for renting. It's logical that they should be kept well. The service charge. Now for the service charge, it's also this is pre-processing, and we do have some outliers, like the one in the 150,000. That is this doesn't make sense, and obviously we have above the
Hassan,
20,000. Yes, yes, Hajam.
Hassan, do you think that this one with 15,000 or whatever, so do you think it's an outlier or a mistake?
Well, aren't they the same thing? Like when, like it could be a
Eh, eh,
mistake and an outlier at the same time.
But if you think logically, the outlier could be someone different from the generic population. Okay, for example, if you think
Mm.
about the heights of the people, some people will be very small, okay, but they are
Yes,
living
yes.
objects. They exist. But in sometimes, if you write, for example, an adult height is a 0.70 centimeters, for example, it could be mistake, right?
Yeah, 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 true,
So
true.
actually,
And I
this
do
is
think this is a mistake, but I
yeah.
just used the
So
term outlier
this okay. Yes.
generally.
So if you check the name of the the concept of the outlier, most probably we believe that the outliers are not the mistakes, that the apparent
Um,
mistakes. They are the
okay.
some divergence in the population. Okay,
I get
if
it.
you think
Okay.
about the colors of the cars, for example, there could be some outliers like purple, for example, but
Mm-mm.
they exist. They do exist in the population.
True.
Yes, but if you think about the construction date after the today, it's not outlier. It's just apparently a mistake. Am I right?
Yes, yes, Hajam.
So as a conception, the outlier does not necessarily mean that the error, but errors are not outliers. Do you
Uh,
understand the difference?
yes, 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 yes. I'll choose
Okay,
my
so be
words more
careful
carefully.
about that. Yes,
Yeah.
because now the let me say something that the detecting the mistakes different than detecting the outliers, because we are sure that we need to remove the misentered values, right?
Yes,
We need to remove. But for the outliers, you have an option. You can remove or keep them because the outliers do exist in the population without error. Do you understand the difference?
yes, 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 Hajam.
Okay, let's continue.
This is the total rent distributed by the location. As we can see, the most of the flats are located in Sachsen and North Rhine-Westphalia. Now, for our third step, the missing values. Uh, Now we have in like our columns, we have 30% missing values in total. So we will be deleting the columns that have 30% missing values. And in total, we have 11 columns to delete. Now, these columns might be metadata or might be just data that are not needed, like they are neither continuous nor categorical. Like, for example, the description, feature where it describes the flats and other features that we thought are insignificant. We deleted those, and also we deleted the features that have very low to no correlation with our target value. Uh, as I said, we deleted the columns without any useful information, like uh, the description, the house number, the picture count. There was also the ID of the advertisement of the house, because this is a database taken from a German website for finding rentals. And we also filled question marks in 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 our samples with labels such as other. or we filled it with the mean value of that feature, or sometimes the most frequent, as we will explain later slides. Like, for example, we had the floor number sometimes was missing, so we just filled it up with 2, which was the most frequent floor number present in our data set. Now, we also deleted, as we have a supervised learning model, so we deleted any samples that didn't have our target value, which was the total rent. Our fourth step was handling outliers. Now we did the box plot to detect any outliers, and we dropped the samples that had any unrealistic uh, values. Now, as you said, Hujam, there are ones that are errors and not outliers. We dropped those two, but we also restricted our values to some extent. So there were also outliers that were dropped. Now here, what we can see, the 500 rooms or the 10 to the power 7 rent. I believe these are errors, are not not outliers, but there were obviously some outliers that were dropped other than the errors or mistakes. How we handled our values, we obviously restricted them to improve our predictions and dropped anything unrealistic. And we kept our values consistent. We made sure of that. So sometimes, like in the area of the flat, we made sure that it's meters squared and not anything other than that. This will be explained in more detail in the next slides. Initial model training and testing. So first of all, we have all these removed features. These are 11 features. Now, for example, the electricity-based price was removed out of our data set because it was included in the base rent. So this is also an example of a feature that might be or that is unnecessary.
So redundancy, right? It's called redundancy.
Yeah,
Redundancy in the data.
it comes again, like in different forms.
So it's called redundancy, okay, in general.
Redundancy,
In
yes.
data, yes, data, if there are some redundant data, you can remove it, okay? Or remember that we have discussed that if two data are very correlated with each other,
Yeah.
we mentioned in the class that they could be redundant data. So removing one of them wouldn't impact the result as much we expect. Okay.
Exactly. I just forgot the word. Thank you, John. And now I'd like for SG Chavash to continue the presentation from on here.
Okay. The second is restricting samples. We had to deal with samples where our base rent or total rent was 0, which was realistically unacceptable. And the floor variable also has to be a sensible number. We also had to remove outliers so that our model would provide better results. We use the select rows widget to restrict our samples to what we thought was sensible in the real world. Then we had to add new values. Since condition had many missing values, we had to create another categorical value called other using the edit domain widget. Then we imputed the values. For categorical values, it was when we researched, it said using most frequent values is practical, and we listed all of the we listed what we did with all of the features that had to be imputed. We had to to change floor from numerical to categorical and then fill it with the most frequent value. Then we changed it back using edit domain widget again. Here you can see all of the things we did with the impute widget. And in the end, we have 149 K instances. We have 18 features. It shows that we have no missing data, so we imputed correctly.
Ezgi, I have a question for you.
Okay.
So actually, you might remember that in the previous presentation, I asked the same question to the other guys. So my question is that you imputed the missing values with several methods, okay, but did you compare the results with the original data with missing data and the data set with the imputed values? Did you compare the results?
The model results, you mean?
Yes, yes, of course. The performance of the same model.
In the later slides, I show the results of the models with no pre-processing whatsoever. We included that because you said it in the previous presentation. We included the non-processed version, the original version, and
okay.
Yeah, we have a screenshot.
Then we will discuss at the end, I believe, right? If we haven't, I mean that if we haven't done this, what would be the result, right? Okay, yes. Because it helps you understand that if your pre-processing really improved the results or not.
Yes,
right?
Yes, I agree.
Yeah, so we need to see this, or maybe sometimes you should go back and add or delete some pre-processing steps so that you might improve better. Okay, let's continue.
Then we had to select a model. Since it is supervised learning we are doing and our target value is continuous, logistic regression, naive bias, random forests, these are better for classification, at least as I researched, that's what it told me. So we decided to use linear regression, SVM, and KNN. You can continue. We split the data set 70% to 30%. These were the initial results without Murat Hoca telling us to fix anything. This and the next slide. And then we move on to building and tuning. Without selecting rows or without imputing, these are the results for our models. This is for the trained data, and this is for the test data. Since we haven't restricted samples and we have missing values, we haven't used impute or restricting our samples with select rows. We have unrealistic results for R2. It shouldn't be, it should be between 0 and 1, but we can see that it's not. The models have no idea what they are doing, basically.
Okay.
Then we tried L1 regression, which is a regularization for linear regression. It can also be used to select features. We tried it with alpha 25, and our result for R2 was 0.991. Then we looked at the test data. It was, there were not a large difference between our train and test data, so it wasn't an overfit, but we also tried it with a low alpha number to see if it would do better.
Ezgi, as I already wrote into your intermediate report, okay, it is okay to screenshot the orange windows, but for the comparing the results, you need to draw some graphs, right? So in the graphs, you can use the bar charts or the linear graphs, line graphs, So we can compare in one screen. If you go back 2 slides back. Yes. So we cannot compare here the train and test with one graph. We have the screenshots, but we cannot see and observe the difference between the train and test data, or with KNN, SVM, linear regression in these two different steps, train and test. So you need to draw a bar chart or something like. You need to put all the results in one graph figure, so we can understand. You remember that I wrote this into your intermediate report as well.
Yes, we will fix that in the final report, but we didn't fix it for the presentation.
So in the presentations, it's not easy for us to remember all these 4 numbers for 3 different methods with train and test data. It's not easy for us.
Yes, I understand, yes.
So the presentation of the findings is important, how to present. So I suggest that, okay, screenshot is okay so far, but when you summarize what you have found, you need to put them into in a good presentation, in a figure, in a somewhere which summarize. When we look at, we need to see all the results in one figure, for example. So try to think about that. Okay, use Excel, for example. Okay, use Excel presentations. So in Excel, you can present in figure or bar chart or whatever. Okay.
Okay, we will include it in the final report. So again, we have a lasso regression with an alpha that is very low. And we can see that in train data, it has better results with 0% 992. And also a better test data result, which was the previous one was 98, this was 99. So if lasso were to be used, it would probably be good to use a low alpha value.
In that result also, we cannot see the effect of the alpha value on that, right? In one single graph.
Yes, yes, right? They are separate. So yes, it's hard to comprehend. I can see that. We can move on, I think. Then we experimented with ridge regression. First, we tried to have a low alpha value as our regularization strength, and it was the same as our lasso regression with a low alpha value. It didn't improve or it didn't get worse.
Okay, Ezgi, I have a question for you for the results so far. If you look at the results, test in the previous slide especially, test on the test data, around 99 R square result, right? Yes. And the mean absolute error, the mean absolute error is 24.641.
No, that's KNN.
It's not important.
Okay.
Yes, it's not important. So the other one is in linear regression, 28 point something. These are 24 and 28 are the euros or mark, right?
Yeah.
So what does it mean, 24.641?
Well, as you explained in the last presentation, for example, if a house's total rent is 400, then we guess it with an error range of minus or plus 24. We might guess 424 or 24 less than 400 in our model. That's what it means.
Yes, and the mean square error and the rooted mean square error, actually it's not good metrics for us to understand the performance of your model on predicting the price, right?
Yes, yes. Mean absolute
right?
error is what we should focus on.
Okay. Can you suggest other metrics? One other metric that gives us more information about the success of your model? Because mean absolute error, as the name implies, is absolute. So do you have any suggestion to use other metric that the orange does not provide here, but which will be very helpful for us understanding your method of success performance? Do you have an idea?
When you ask like this, I can't think of anything right now.
Okay, Hassan, what about you?
Hocam, can you repeat the question again?
Yes, of course. Your idea in the first presentation, as you expressed, to predict the rental price of an apartment house in Germany, right?
Yes.
So R-square does not provide this. R-square just shows the relationship between your prediction and the real values. And the mean absolute error just provides you the errors in absolute values, and they are mean. I am saying that RMSE and MSE, they are not good metrics for your purpose, prediction
Yes.
of the rest. I am saying that MIE, yes, you can use this, and as he has explained that, it is the plus and negative 24 euros in your prediction error range, okay? But I am asking that, do you think that another metric that is useful for us to understand the success of your proposed method?
Another metric other than the mean absolute error.
Exactly. Because let me ask you, what does mean to you 24 euros error?
It
What
just
does
means
it mean?
there's
Is it too
a
much
plus
or too low?
minus. Well, when you look
Okay,
at the
plus or
rent
minus.
prices, when you look at the rent prices,
So,
it's like the average is 900. So I think 24 plus minus is not that much of a difference.
so what would be another metric for that reason? By directly looking MAE, do you think that you can understand the performance of your model?
Well,
Directly looking at,
I believe that yes.
Ezgi, do you think that when you look at only the MAE, the absolute error, 24, 28, can you really understand the performance? Is it good or is it bad, your model? Can you understand only looking at that values, 24, 28, 351, why it's good or not?
I think we can only we can't talk about good or bad, but we can just give our results. Like if you use this model, it will have an error rates. Like be prepared, we can tell the customer. But I think it also depends on what is expected of us in real life, in a real world situation. For example, if they are able to tolerate our mistakes or not.
Okay, if I were you, I would use the percentage of absolute error. Percentages.
Why, hocam?
So, you understand? Because if the rent is 1,000 around,
True.
24 over 1,000, then you could say that my mistake is around 2% around the nominal price. Do you understand?
I understand. Yes, it makes
hocam.
sense.
But
Okay,
it's because we know the average rent price, hocam.
Yes, you know the average price, or you know the real price actually, right? Then you can calculate the expected, but not the mean absolute error, but you can calculate the mean percentage error.
Yes.
Yes. It would be easier and more general.
Then you can tell, you can tell that my model in prediction, it has an error rate 2% of the real price, 1% of the real price. I don't know. Do you understand my
Okay.
question and answer?
Yes,
Yes.
definitely.
Yes.
Okay, you can do this. How can you do this in the orange? You know that you can save the prediction result, right? As a CSV file.
Yes.
Then in an Excel sheet, you can open the real prices, rental prices, and expected prices. You can do a very simple arithmetic calculation, then you can report.
Okay. Okay.
Okay, hocam.
We
Do
understand.
you understand? Do you understand me clearly?
Yes, we
hocam.
can add it to our final report.
Yes, please add this final report. I'm saying that this is the mean percentage error, right? Then
Okay.
we can understand that what is the difference between SVM and KNN in prediction of the rental price better. Let's continue.
Okay.
Then we tried ridge regression with an alpha of 12. Can you go back one slide?
Yes, sorry.
There we can see the linear regression results in our train data and our test data, which didn't change. Then we tuned the KNN. We didn't change the metric and the weight. We experimented on the neighbor size. This is our result with a number of 10 neighbors, which is better than linear regression, but it could be better, I think.
I have a last question for you. Why SVM is too bad? Why it does
Actually,
not good or average?
These are because we didn't hyperparameter tune the SVM yet. We will do it on the we will do it last.
Okay, let's go.
And you can see that our test data it drops to 99%, 0.99. Then we tried it with a number of 2 neighbors. And although our train data was better.
Okay, as I suggested, please put all these kind of results into one graph so we don't waste time and we can understand easily.
Okay. Our test data, however, our R2 result dropped. So using 2 neighbors probably isn't a good idea. And then we got the highest results for both test while using 5 neighbors, which is the default value. So we decided to stick to 5 as test data is more important than the train data, I believe. Now we try to tune the SVM. We had already selected linear kernel. For example, we increased the iteration limit. We did lots and lots of tries. We didn't include everything here. But iteration limit is best when it is 1,000 and our numerical tolerance as shown. With our cost 1 and our regression loss epsilon 0.1, these were the results of our SVM, which aren't very good, although better than the initial results. We could still, I believe, improve it. And we didn't include everything, but with our cost 1.3 and our regression loss 0.6, we have a 0.97 R-square results on our test on our train data, and the 0.98 on our test data. This is it for the presentation. Do you have any questions?
So I hope that you noted my questions.
Yes.
So you need to improve your final report and then add these up, okay, into the final report. And so my question is that what's your final model. So what is the result? What are the results with that final report? It's unclear. What's your final report? The final model, which you choose.
Between the KNN, SVM, and linear regression.
So my question is that which one of these models is your final model, and what is the accuracy or what is the result for that final model? Which one is your final model?
Well, Hojam, they all have high performances actually, and I don't know. I don't think we decided.
But you
I
should
think
decide. Okay.
I think we will probably choose the KNN because KNN is the best so far.
Hassan, will you choose KNN for that problem?
Well, it does have the highest on the training, and on the test, it's also like as good as the linear regression, and I think it's a simple model. So I think we can go for it.
Are you sure, both of you? Are you sure that you can use KNN for your problem? $1 million question. $1 million question.
I would expect linear regression to perform better.
No. We are not comparing. I am asking that. Are you sure that you can use KNN in your problem? I'm asking a direct question. I don't compare anything with anything. I'm asking one question. Are you sure that you can use KNN in your problem? Do you remember the discussion in the class about regression with KNN? I gave you a very important trick about it. Do you remember, Hassan?
I don't recall, Hojam.
Okay, what about you, Ezgi?
What do you mean by
trick? I gave you very important rule or very important explanation, and I showed you the explanation with an example, RAM prices. Do you remember? No? Anyone remembers in the other groups? Anyone in the audience? Nobody remembers in the audience? Eta, Mert, Bilge. Nobody remembers.
I remember the rent prices, but I don't remember
Not rents.
the
RAM.
trick.
RAM.
Oh, okay. Then I don't remember the RAM prices.
RAM prices. I showed as a graph as well. Nobody remembers. In the audience, do
I
you
remember, teacher.
What was that?
From deep learning.
Not deep learning. KNN is not part of the deep learning. But in KNN, I explained that KNN cannot project the prices for future, right? KNN only predicts the prices which exist in the trained data. In linear models, you can use the predictions, right?
Yes.
KNN, that's why I was surprised when KNN did better than linear regression.
It can do better because you are in the test data. The test data comes from the trained data. I mean the collected data. But tomorrow, if you want to predict the price with the updated price because of the inflation, the KNN still keeps predicting the same prices. It cannot make a projection. Remember that in the RAM prices?
Yes,
prices?
Yes,
see
yes,
that?
yes. Yes, I remember.
Everybody remembers right now. So if I were you, I wouldn't use KNN because of that reason. If you have expressed this argument, you would get 100 points, $1 million. But now you lost $1 million. Okay?
Yes, I understand.
Okay. Anything you would like to add to your discussion presentation? Okay. Hasan?
No
Okay.
hocam. I think
Ezgi?
it's done here.
Ezgi?
Yes, yes. We should use linear regression, and I have checked again. Linear regression and KNN, they both have the same results for our test data. So I was wrong. It wasn't better.
Okay. So as a last point, I would like to kindly remind you that before conducting a presentation, please well prepare for that presentation with your hardware, software, and your skills. And if you are a team, please do a rehearsal and tasking each other and do a rehearsal, and so that you are ensure that you are ready for the presentation. It's not good habit to wait the others in the presentations. Okay, it's not professional. Do you understand my remark?
Yes, hocam. We're sorry for that.
Yes, hocam
Okay,
cidden hiç yani hiç aklıma gelmezdi böyle bir şey olacağı. Özür dilerim.
Okay, so do a rehearsal before the conducting the real presentation. Okay, thank you for your presentation. Please improve your final report as well.